Welcome to Module 1, Introduction to 3D Designing in the Textile and Fashion Sector. In this modules, you'll see how digital files become physical parts that integrate beautifully with textiles. In this chapter, you'll gain a clear map of 3D processes, a small software toolkit, 5 design rules that prevent failures, fabric attachment methods, safety basics, sustainability pointers, and how to brief a European service bureau. Are you a fashion designer, a 3D printing specialist, or a sustainability expert? Then this is the place for you. Designers, pattern cutters, product developers, and small studio founders. No engineering degree required, just curiosity and a willingness to test ideas with small printed samples. In Europe, policy is accelerating change. Eco-design for sustainable products regulation, digital product passports, and extended producer responsibility. Good records now simplify compliance and reorders. Set a realistic expectation. 3D rarely makes whole garments at mass scale. Its power is integrating printed elements, buckles, appliques, shells, tools, into garments with sewing, bonding, riveting, or direct-to-fabric printing. Learning outcomes. By the end, you'll match designs to processes, model cleanly, export reliably, attach to fabric, work safely, document builds for digital product passports, and understand the EU policy context shaping our choices. Chapter 2. Why 3D now? EU policy and timing. Why now in Europe? The EU wants durable, repairable, traceable products. 3D workflows are precise, logged, and ideal for local, on-demand batches. Great for capsules, prototypes, spares, and custom parts. ESPR, the Eco-Design for Sustainable Products Regulation, is in force. It enables digital product passports and a staged ban on destroying unsold textiles and footwear. Good records will matter. Extended producer responsibility for textiles is also coming. Producers will help fund collection, sorting, reuse, and recycling. Design choices that ease repair and recycling become business choices too. The AM market matured. Strong EU service providers, robust software, and materials like PA11/PA12. This lets small studios design in-house, then outsource reliable batches to nearby bureau. Takeaway: policy pull plus tech push. If we store clean geometry, material IDs, and process logs today, we'll be ready for tomorrow's compliance and faster reorders. In chapter number 3, we will take a quick look to process overview. Material extrusion, FDM/FFF. A heated nozzle draws filament rods. Use TPU for soft badges, meshes, and flexible reinforcement. Use rigid filaments for quick prototypes. Surfaces show fine lines. Support snap away. VAT photopolymerization, SLA/DLP. Light cures liquid resin into very smooth, detailed parts. Perfect for jewelry masters, buttons, and mold tools. Handle resins with gloves. Wash and UV cure fully. Polymer powder bed fusion, SLS or MJF. Nylon powder fuses layer by layer without support scars. Ideal for small batches of buckles, clips, heel counters, and structural trims. Easy to tumble and dye. Material jetting, polyjet/textile. Jets multiple photopolymers to create color and different shore hardness. Textile can print directly onto tensioned fabric for striking color and textures. Binder jetting, useful for color prototypes and models at bureau. In fashion, we use it mostly for presentation pieces where vivid color matters more than mechanical strength. Metal additive manufacturing. Outsource stainless steel parts or print castable masters for precious metals. Great for durable hardware. Finishing still relies on traditional polishing and coating craft. Name processes with ISO terms when briefing partners. Material extrusion, VAT, photopolymerization. polymer powder bed fusion, material jetting, binder jetting, and metal AM. Shared language prevents costly misunderstandings. Choosing quickly, flexible wearables, TPU, FDM, or polyjet elastomers. Tiny relief and smoothness, SLA/DLP. Strong batches, SLS/MJF nylon. Full color, polyjet or color MJF. Metal hardware, Bureau Metal AM. Now let's take a look to some software toolkits. Start where the garment leads. Use CLO 3D or Browseware to place appliques along seams in stretch directions. Export with explicit scale and units to avoid centimeter-millimeter mix-ups. For organic or sculptural detail, use Blender. The 3D print toolbox checks wall thickness, non-manifold edges, and flipped normals, so you catch problems before slicing. For exact fits and parametric families, use Rhino with Grasshopper or Autodesk Fusion 360. Fusion's volumetric lattices make lightweight, flexible structures practical. Slice and prep. Cura or Prusa Slicer for FDM. Preform for resin. Bureau use Materialize Magics and EOSPRINT for SLS/MJF. Preview layers to place supports away from show faces. Prefer 3MF when color or multiple bodies matter. STL drops units and material info, while 3MF packages geometry, units, colors, and textures together. Take notes. These 5 design rules will keep your projects looking sharp and mistake-free. Rule 1. Lock units early. Use millimeters across apps and write _MM in file names. Many scale errors are 10 times mistakes from mixed units on export-import. Rule 2. Watertight meshes with outward normals. Fix holes, self-intersections, and flipped faces. Use Blender's 3D print toolbox or a Bureau's Magics checks. Rule 3. Minimum thickness. Start around 0.6 to 1.0 millimeters for resin, 1.0 to 1.2 millimeters for TPU, and about 1.0 millimeters for SLS/MJF nylon. Increase for large spans or heavy loads. Digital fabric needs functional behavior and look. Focus on weight, stretch, thickness, and surface texture. Accurate materials make later fit and design decisions more reliable. Rule 4. Orient to protect show faces. Put supports on hidden faces. Angle resin parts to reduce peel forces. Align FDM layers with expected loads. Rule 5. Provide drain or escape holes. Resin parts trap liquid, nylon parts trap powder. Add generous holes and place them for easy washing or depowdering. Clearances. For moving or assembled nylon parts, begin with 0.5 to 0.7 millimeter gap. Print a small coupon with several gaps to test, then reuse the winning value. Now we'll walk through the entire process, step by step, to see how everything connects from start to finish. Workflow snapshot. 1. Write the brief. 2. Choose process and material. 3. Model. 4. Validate and export. 5. Slice or nest. 6. Print, finish, assemble. 7. Document for reorders and compliance. Brief smarter. Record use, location on body, feel, finish, quantity, deadlines, care needs, and any compliance notes. These choices point you to the right process early. Build prep in practice. Cura intent profiles balance speed and surface. Prusa Slicer's variable layers save hours. Preform auto-orient supports. Bureau auto-nest hundreds of parts in powder beds. Post-processing. FDM supports off. Sand or vapor smooth if needed. Resin parts wash in IPA, then UV cure. Nylon parts depowder, tumble and dye. Ask for a target RAL or Pantone. Assembly to textiles. Sew through 2 millimeter stitch holes or recessed channels. Heat bond with TPU films using press temperature, time, and pressure. Or print directly onto fabric with Polyjet textile. Validate with quick tests. Simple ISO 2411 TPL strips for bonds. ISO 6330 domestic wash cycles to check color and adhesion endurance. Keep notes with your files. Great design isn't just about how it looks, it's about keeping people safe and building a sustainable future. Safety first. Printers emit ultrafine particles and VOCs. Enclose and ventilate with HEPA plus carbon filtration. Separate resin wash and powder handling. Never leave printers running without active HVAC. Personal protection. Nitrile gloves for resins and solvents. Eye protection. FFP2 or FFP3 respirators and anti-static measures for powder handling. Keep safety data sheets and spill kits at workstations. Sustainability levers. Batch parts densely. Choose PA11 or Hyrus Ability PA12. Use industrial dye systems with documented color fastness and record recycled or bio-based content in your part files. Digital product passport mindset. Store geometry, materials, process logs, finishing steps, care and repair notes. The same bundle supports reorders, quality, and future compliance. Economics. AM shines for one-offs to a few hundred parts. Beyond that, consider a hybrid route. Iterate with AM, then shift to molding or cutting when volumes justify tooling. Be precise. Quantify savings. Avoid vague claims, log assumptions, and cite sources. Align data with ESPR and DPP fields so improvements can be verified later. Now it's time to put everything into practice. Exercises, real-world briefs, and the common pitfalls to watch out for. Avoid too thin walls, non-manifold geometry, tight clearances, and sharp corners at stress points. Orient for function, not only cosmetics. State part use, process, material and finish, quantity, color, tolerances, delivery date, and approval reference. Ask for build photos and material certificates. Briefing a bureau. State the ISO process, material, quantity, and deadline. Send 3MF in millimeters. Indicate finish and dye color. Request a witness coupon and a build log with material batch. Common pitfalls to avoid. Mixed units causing 10 times scale errors, non-manifold meshes, tooth-in walls, missing drain or escape holes, supports on show faces. All preventable with today's checklist. Quality loop. Each time you change material, supplier, or orientation, print a small coupon to validate thickness, clearances, and finish. Record what works and reuse it. What to keep. Source files. Exported 3MF/STL. Slicer profiles. Printer or bureau details. Material batches. Finishing steps. Test results and care notes. This becomes your reusable knowledge base. Where to keep learning. ISO/ASTM 52900 terminology. The 3MF specification. Vendor design guides from Formlabs, HP and Materialize, and EUOSHA safety pages. Trusted, current, and citation ready. Chapter 9. Wrap up, recap. You now have a working vocabulary, a minimal software stack, 5 design rules, a safe workflow, and a plan to document your builds for compliance and reorders. Download the chapter and templates. Then continue with Module 2 for tool deep dives and Module 3 for methods and practice. Tip for teams. Share a one-page Studio SOP with safety, export, and pre-flight checks posted by the printers. Consistency saves time and keeps quality high. Remember, refer in ISO terms with partners, prefer 3MF for complex jobs, and ask Bureau for build logs. You'll get faster quotes and more repeatable results. Thank you for learning with SUST 3D Fashion. Proceed to the quiz to check your understanding, then continue to the next modules for more learning material.